Okay, we're carrying on and we are on page 82, so let's dive straight in. We were looking at an example, we asked you to look at an example to determine the cost of drilling a hole, an oil well. Okay, right, and so we start off with some numerical examples and we're hoping that these are really easy. We're going to write it down in terms of the sort of thinking. So there's 5,000 Rand, that's a fixed cost. And then we're going to take the depth of the hole times by the cost per meter, so 10 times 30. Right, that comes to 5,030 Rand. Okay, what will a 50 meter hole cost? 5,000 plus 50 times 30. Right, 50 times 30 is 1,500. Okay, that's easy to do because 5 times 3 is 15, and each of them's got a 0 on, so it's 1,500. Okay, and then add that to the 5,000, so we're going to get 6,500. Okay, now, what will a hole cost that is h meters deep? And what we want to show you here is the only thing that's been changing here is the depth of the hole. That's the only thing that's varying. That's the variable. So if a hole that is h meters will just be 5,000 plus h times 30. All right, there it is. That's the depth. Okay, now let's simplify that a bit, because when we write algebra, we know that we don't write that. We prefer to just save a bit of space and time. So 5,000 plus 30h. 30h means 30 times h. That's the way we prefer to write it. We cannot add the 5,000 and the 30h. We'll get more into that, but they're kind of different things, so we just leave it like that. Right, now, if I spend 8,000 Rand, how deep was the hole drilled? Okay, so let's think about how we're going to work this out. Well, that 8,000 Rand wasn't all spent on drilling. 5,000 of it was spent getting the rig onto my site, to my house. Okay, so I must take 8,000 and subtract 5,000. All right, now that is how much I spent drilling. And then I must divide that by 30, because 30 is the rands per meter. So 8,000 divided by 5,000 is 3,000. We can do that in our head, surely. And we can also do this in our head, because we can divide a 10 off both, and we can divide both by 3. So in fact, the answer is 100 meters. Okay, let's pause the video briefly and try and do this next example. If I spent 5,150, how deep did we drill? Yeah, that's right. 8,000. Sorry, not 8,000. Goodness. 5,150 minus 5,000 divided by 30. Okay, so we actually get 150 divided by 30. Also easily done in our heads, because we can divide the top by 10 and the bottom by 10. Right? And so we get 15 divided by 3, we get 5 meters. Okay, now if we look at these two expressions, that is the kind of, that's different in each case. So if I spend k rands, then how many meters did he drill? Well, we're going to just plug k where those numbers are, where those green numbers are. We're going to take the total, we're going to minus 5,000, because 5,000 is what we spent to get the oil rig to the property. Okay, so this number here at the moment is how much we spent on drilling, but each meter costs 30, so we must divide by 30. Does it make sense? It always makes sense. Okay, right. The next example we're going to look at is a sort of little flow diagram, which shows a kind of process of what's happening. So, suppose a number is multiplied by 3, and then 5 is added to the result. So we've got a number x, and it's multiplied by 3, then 5 is added to the result. Okay, So we could draw this in a little flow diagram. We start off with x, we multiply it by 3, that's then called 3x, and then we add 5, and there's our answer. Right, so we're going to do one together, and then we're going to ask you to pause the video and try a whole lot of these yourself. B is doubled, and then 1 is subtracted from the result. So we start off with B. We're going to double. What will we call it when we double B? And double means multiply by 2. 2 times B, but we don't need to write the times sign, just 2B. And then we're going to subtract 1. Subtract 1. Okay, and our final answer, 2b minus 1. Okay, we want you to pause the video and we want you to try the rest of the questions on this page and then let it play again and see how you went. Okay, so we start off with m. We square it. How do we write that? That just says m squared. Then we add 3. Final answer, m squared plus 3. Okay, the next one. X has 3 added. So this is going to be x plus 3. Now we're going to double. Okay, and we can do this in a couple of ways. We can go straight to the answer. If you double, we're going to double both pieces. And I'm just going to show you, if we had 4 plus 7, what is 4 plus 7? 4 plus 7 is 11. Okay, if we wanted to double that number, we would need to double both the bits that make it up. In other words, if we doubled, it would become 8 plus 14, which is 22. We can't just double the one piece. So the answer here is actually going to be, we're going to double the 2, and we're going to double the 3. That's doubled. Okay? You might say, Paul, can we write this? There's our number, and we want to double it. We want to multiply it by 2. So we're going to put 2 in front. When there's no sign there, that means 2 times. That is absolutely correct as well. Both of these are correct. And later, we're going to have a name for this. There's a rule for that. But okay. But it actually makes sense. Right. D. We find the square root of t and then add 5. So we're going to square root the square root of t. Then we're going to add 5. Final answer, square root of t plus 5. Okay. We add 5 to t and then find the square root. Okay, so this is a different order. Same operations, but a different order. And order matters. So here's t. We're going to add 5. We'll get t plus 5. And then we're going to square root. So we're going to put all of that under a square root sign. And notice that these are different things. Those two things are completely different. Okay, pause the video and try all of the ones on page 84. Okay, and then we'll let it play again and we'll go over them. Okay, multiply p by 7 and then add 3. P times by 7, multiply by 7. Multiply by 7, sorry. 7p. Add 3. 7p plus 3. Alright. Add 3 to p. P plus 3. Now multiply by 7. Okay, and it's going to be like this. 7 brackets p plus 3. Or you might say, Paul, can we just multiply the 7 by p? Yes. And the 3 by p? Yes. Both are equally good. Okay. Raise x to the power of 3. That'll give us x cubed. And then halve the result. Now, we can write this in two ways. We can either write it as half of x cubed, like that, okay? Or we can write it as x cubed divided by 2. Both of those things are equivalent. All right, square u and double the result. So we're going to start off with u. We're going to square it. We're going to get u squared. U squared, sorry. Then we're going to double the result. Double. Okay, and that will be 2 times u squared. All right. Now we're going to do the same things, but we're going to do them in a different order, and we get a completely different result. Okay, we start off with u, we double it, we get 2u. Now we're going to square that. Okay, now remember, square means multiplied by itself. So in fact, what we're going to do, we're going to take 2u and we're going to multiply it by 2u. All right, and let's just think about that. We've done some work on exponents. 2 times 2 is just going to be 4. And u times u, the short way of writing u times u, 4u squared. Okay. Add 6 to e. And then subtract 6 from the result. Now we've got e plus 6 minus 6. So you might say, oh, is the answer going to be e plus 6 minus 6? Yes, it is. But can we simplify that? Of course we can. We just get back to e. All right? These operations, adding 6 and subtracting 6, are called undo operations. The one operation undoes the other one. Okay? They also, and we'll get to that term much later, in fact in grade 12, they're also called inverse operations. Okay, multiply g by 9. Okay, we get 9g. And then divide the result by 9. Divide your answer by 9. Okay, so 9g divided by 9. And the answer to that is obviously just 1g. Okay, now there's 3 more, which if you haven't tried, quickly try them. Pause the video and try them. Okay, and let's have a look. Square n and then square root. The result. Now, when you square root a number squared, you actually get back to the same number. You might want to check that with an actual numeric answer. So in other words, if n was 9, what is 9 squared? It's 81. And what's the square root of 81? It's 9. Okay. Now, there's one where we do the same things but in different order. Start off with n, square root it. So we get that. Okay, and then square the result. So now what we've got the square root of n times by the square root of n. Okay, and that just comes to n as well. And again, it might make more sense for you if you think about it with a number. So suppose we start off with 9 here. When you square root 9, you get 3. When you square 3, you get 9. Squaring and square rooting are undo operations of one another. They take us back to where we started. They're also called inverse operations. Okay, now there's loads of space here for you to make up some more, and you can test them on a friend. Okay, so we're going to ask you to do that for homework, not now during the lesson, but later. All right, we're going to now go to page 86. All right, and we are going to now write down algebraic expressions for things. The number of days in W weeks. And I can see a lot of you saying, how do we know? We don't know what W is. Okay, so what I want you to think about is, let's put a number here. If I said, how many days are there in 3 weeks? How many days are there in 3 weeks? There are 21. How many days are there in 10 weeks? There are 10 times 7. This 21 is actually 3 times 7. How many days would there be in 5 weeks? It would be 5 times 7. So what am I doing to the number of days to get to the number of weeks? I'm multiplying by 7. So in W weeks, there will be 7 times W. And the way we write 7 times W is just 7W. Okay, right. Let's think of a number that's 3 bigger than B. Okay, 3 bigger than B. And again, let's go back to numbers. A number that's 3 bigger than 8. Well, it will just be 8 plus 3, won't it? All right? So a number that's 3 bigger than B will be B plus 3. Okay, the B is just replacing a number. A number half as big as X. How do we halve a number? Well, either, let's say a number half as big as 10. We could either take our 10 and divide by 2, or we could write a half times 10. Now, the number's not 10, it's X. So, X over 2, or a half times by X. Okay, let's just move that X just ever so slightly closer so it doesn't fall off the edge of the page. Okay, right. The number represented by D dozen. How many is a dozen? That's right, a dozen's 12. So what would 3 dozen be? Three times 12. What would 5 dozen be? Be 5 times 12. What would D dozen be? D times 12. Do we write it like that? No. We write 12D. Okay. Right. The number of people in C couples. Now a couple is 2. So if we've got 4 couples, it's actually going to be 4 times 2 people per couple. Right? The answer would be 8. But it's actually more useful to see it in that structure. If we have C couples, we must take C and we must multiply it by 2. That's our answer. But we don't really write the answer like that. We'd rather write it as 2C. So we take the number of couples and we multiply by 2. Does it make sense? It always makes sense. A number that is 5 less than G. 5 less than G. So this may be a little bit tricky. 5 less than 10. Oh no, let's not go with 5 less than 10. Let's go with 5 less than 11. What is 5 less than 11? Well, the way we'd work that out, we would go 11 minus 5. The answer is actually 6. So a number that is 5 less than G would be G minus 5. There's our answer. Okay, we hope that you're seeing the structure, because what's changing actually is just this. All right, so put numbers in. Double x and then add 5. Okay, well the way we write double x, 2 times x plus 5. We should be good at that from our flow diagrams. Multiply y by minus 3 and then subtract 2. Y times minus 3 we write as negative 3y minus 2. The number of people in B soccer teams. Okay, well in one soccer team there are 11. In 4 soccer teams, how many people would there be? 4 teams. We would take our 4 multiplied by 11. Okay, we get 44. So in B teams, we'll take our B and multiply it by 11. And we get 11B. Okay, all right. There are loads of these. We want you to, we're going to stop there. We want you to try the rest of these, before we next see you. Okay, and that'll bring us to the end of this module. We'll quickly go over these next time. All right, and then we'll start module 8.